All right, so now that we're armed with a new definition related to right triangles, it turns out that we can actually find some more exact values or specific values of more angles. So again, note in a lot of our discussion, we don't even know what the angle is. We just know what the output is for the angle that's got the information I have. But here, we're going to actually find actual values. Now, we've actually previously done this with the quadrantal ones, right? We know for 0 degrees, 90 degrees, 180 degrees, and 270, and then all the way back to 360 being coterminal, right? We have discussed what the values of those guys are, right? They're usually 1 or undefined or 0 or something of that nature. So we've actually found some values for the quadrantal ones, but now, right, we're going to find some values for some very special angles. And it basically goes back to our special right triangle situations. So what do we know about our special right triangles? Well, the easiest of the two is a 45, 45, 90, right? We found, right, that in a 45, 45, 90, so let me go ahead and I'll orientate myself to kind of match the first quadrant, right? In this, right, what we basically have, this is 45 degrees, and this is 45 degrees, there's my 90, and we know that it doesn't really matter, right? Both sides are equal to each other, right? So this side is x, this side's x, and this guy is the square root of 2, right? If I would just go ahead and let x equal 1, right, because again, because of the similarity of this, right, we basically have 1, 1, square roots of 2, 45, and 45. So now, what's also nice about this, it doesn't really matter which angle I use. For this 45 degree angle, there's its opposite. For this 45 degree angle, there's its adjacent, all right, and then there's its hypotenuse, all right, and then of course it works the same. For this angle, there's the opposite. For that angle, there's the adjacent and that one. So how about, since it's the same for each one, right, we'll just use that. So for 45, there's my opposite, there's my adjacent, and there's my hypotenuse. So we can now, right, let me go ahead and come back down here. Places where you see 45 degrees, we can actually now start finding exact values. And so we know that sine of 45, well, with our new definition, is the opposite over the hypotenuse. And so for the situation, we have the opposite is 1, and the hypotenuse is the square root of 2. So rationalizing the denominator, we find the sine of 45 degrees is equal to the square root of 2 over 2. So we now have an exact value, all right, for that. Cosine of 45, right? Well, we know that to be, by our new definition, that's the adjacent over the hypotenuse. So for our 45, the adjacent is 1, the hypotenuse is the square root of 2. And again, rationalizing the denominator, we find that the cosine of 45 is also the square root of 2 over 2. So kind of a rare instance where sine and cosine are actually equal to each other. What about the tangent? Well, by definition, it's the opposite over the adjacent. For 45 degrees, the opposite and the adjacent are both equal to 1. So the tangent of 45 degrees is equal to 1. All right, and so I know for me personally, I would ask you guys to commit these to memory. We do a lot of things in applications with the 45 degrees, 30 and 69 angles. So you're going to help yourself by committing them to memory. But I know what I used to do as a student is I always remembered what this triangle, this right triangle, looked like for a 45. And then when in doubt, I can just use the relationships opposite, adjacent, hypotenuse. So if I ever tended to forget off the top of my head what the sine, the cosine, and the tangent of 45 degrees were, I would just draw myself a really quick right triangle, and then I was able to get it. So that might be the way that you can, do it as you commit it to memory. What's another situation? Well, the tougher one, as we saw with relationships, is a 30, 60, 90. So let's first consider the 30 degree. Again, just for simplicity, I'm going to go ahead and try to make this a nice quadrant 1 orientation. There's my 30 degree angle, right? And what we learned in a 30 degree situation, right, is what we have is this side opposite it always determined everybody else. All right, so that's what we learned a while ago. Again, if I was to let x equal 1, this relationship now turns into right? There's my 30 degrees. This is 1, this is square root of 3, and that's 2. And so for a 30-degree angle, here's your opposite, here's your adjacent, and there is your hypotenuse for that 30-degree angle. And so we can now come down here and find some exact values. So what's the sine of 30? Well, again, by definition, it's the opposite over the hypotenuse. And for this 30-degree angle, we have 1 over 2. So the sine of 30 degrees is 1/2, or 0.5. Cosine of 30, well, our new definition, it's the adjacent over the hypotenuse. And in this situation, we have the square root of 3 over 2. So the cosine of 30 degrees is the square root of 3 over 2, right? Adjacent over hypotenuse. The tangent is defined in our new definition as the opposite over the adjacent. And so when I look at my situation, the opposite is 1, the adjacent is the square root of 3. Rationalizing my denominator, we get that the tangent of 30 degrees is the square root of 3 over 3. So there you have it. So there's what the sine, cosine, and tangent are for 30 degrees. And of course, by default, we have the other 3 by just using reciprocals. But there they are. Again, lots of information to commit to memory. What I used to do again as a student way back in the day, and even to this day when I tend to forget, I just draw myself a really quick 30, 60, 90 right triangle and get a feel for opposite, adjacent, and hypotenuse if I ever tend to forget. So maybe again use that skill. Last but not least, we also have the 60-degree angle. So let me go ahead and redraw our 30, 60, 90, but things are going to be a little orientated differently because there is the 60-degree angle for this picture. And now, because of where this angle's at, who's opposite and who's adjacent is going to change. So remember, this side is x, right? This side is still 2x, and this side is still x square roots of 3, right? Because of the 30-degree angle that's there. Again, if we let x equal to 1, this right triangle now becomes, there's my 60, that's 1, square root of 3, and 2. And so for this 60-degree angle, this side is now the opposite, this side is now the adjacent, and this side is still your hypotenuse. So again, because of where my angle is, the side opposite, again, same triangle, but because we're talking about this angle up here rather than 30, the concept of opposite and adjacent with respect to that angle also changes. So that means our values are going to change. So what about the sine of 60? Well, again, by definition, it's the opposite over the hypotenuse. And in this case, my opposite is the square root of 3, and my hypotenuse is 2. So the sine of 60 degrees is the square root of 3 over 2. Cosine of 60, well, again, by our new definition, it's the adjacent over the hypotenuse. In this case, the adjacent is 1, and the hypotenuse is 2. So the cosine of 60 degrees, right, will be 1/2. Tangent of 60, well, again, under our new definition, it's the opposite over the adjacent. And in this case, for 60 degrees, my opposite is the square root of 3, and my adjacent is 1. So the tangent of 60 degrees is equal to the square root of 3. So there's some more values. So there's all your values for 45, 30, and 60 degrees. And again, as you try to commit these to memory, here I am almost 40 years later, if you would, right? I still, in my mind, I kind of still have these pictures in my mind if I ever tend to forget. Last row, let's go ahead and play around with the other types of 3. So cosecant, well, again, by definition, cosecant is the reciprocal of sine. So our new definition is hypotenuse over opposite. We're talking about a 45-degree angle. So for this situation, the hypotenuse is the square root of 2, right? And the adjacent is 1. So the cosecant of 45 degrees is equal to the square root of 2, using our new definition. Secant of 30, well, that basically is the reciprocal of cosine. So our new definition is the hypotenuse over the adjacent. So for my 30-degree angle, the hypotenuse is 2, and the adjacent is square roots of 3. So in this case, we'd have to rationalize the denominator. So the secant of 30 degrees is 2 square roots of 3 over 3. So there's that using the new definition. Of course, we could have just used a reciprocal right here, right, and gotten pretty much the same thing. Cotangent of 60. What we have here, by definition, this is the adjacent over the opposite. So when I go look at my 60-degree angle, right, the adjacent is 1, and the opposite is the square root of 3. So rationalizing my denominator, we see that the cotangent of 60 degrees is the square root of 3 over 3. Alrighty, so there you have it. So we now have quite a toolbox full of, we know what the exact values are for the quadrantal angles, and we now can find the exact values for special right triangles. And to give you guys a heads up, it's a great way for me to get you guys off the calculator, right, and using definitions by asking you to find exact values. Because if you're giving me a decimal, I know you're using your calculator. If you give me the square root of 2 to 2, I know you have some understanding. And that's where we need to head. All right, so more on this later. We actually have some new identities now, and I'll do that in another video.